Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will solve the limit when x goes to 0 plus of 1 over x to the power of sine of x. Anytime that you see a variable, which is, there is an x here, so it is a variable. So this is a variable to the power of another variable, which is sine of x. All the time think of putting y equal to 1 of x sine of x. Yeah? And then the second step that you're always gonna do, you're gonna apply ln of y equal to ln of 1 of x to the power of sine of x. So this should be like a second nature. Whenever you see a variable to the power of a variable, we have to apply those two rules. This is the only way to solve that problem. And now, if I want to study the limit when x goes to 0 plus of ln of y, I can, which is equal to the limit when x goes to 0 plus of ln of 1 over x sine x. Yeah? And so we will concentrate on that part of my equality. And I know that with the logarithmic rule, I can bring the sine x here. So it is the limit when x goes to 0 plus of sine x ln of 1 over x. Yeah? And if I look at this, sine x ln of 1 over x, it seems complicated to find the limit of it, because ln is infinity and sine 1 over 0 plus is infinity, and ln of infinity is infinity, and sine x, when x goes to 0, it is 0. 0 times infinity, I don't know, you cannot do it. So I will try to use L'Hopital rule, but to use the L'Hopital rule, I need a numerator and a denominator. And so let's see if I can split this into a numerator and denominator, which is very easy to do. I say this is equal to ln of 1 over x divided by 1 divided by sine x. But I forgot to put the limit here. Limit when x goes to 0 plus. So now I will apply the logarithmic rule to that part too. I know the ln of something divided by something, it is ln of the numerator minus ln of the denominator. So this is equal limit when x goes to 0 plus of ln of 1 minus ln of x divided by cosec of x. 1 divided by sinus is cosec. And again, I know that ln of 1 is equal to 0. This is equal to 0. So let's write it. It's equal ln of x divided by cosec of x. And now ln of infinity is infinity and cosec of x is infinity, because cosec is 1 divided by sine x, and when x goes to 0 plus, so sine of 0.00001 is a very small number, which is 0.000 infinities of zeros and then 1. And if 1 divided by 0.00001, I have to multiply the numerator and the denominator by as much number of zeros I have before the one with a huge number, but I have to do it in the numerator again. It becomes infinity divided by infinity. So now I keep on forgetting to put here equal to the limit when x goes to 0 plus. So now I can apply L'Hopital rule. Which is the derivative of the numerator divided by the derivative of the denominator. So the derivative of, there is a minus here. I forgot to put it here. There is a minus here. because ln of 1 is 0 and there were a minus here. And now I know the derivative of ln of x is 1 over x, but there is a minus here, so it is equal to the limit when x goes to 0 plus to minus 1 of x divided by derivative of cosec of x is equal minus cosec of x cotangent of x. Here minus divided by minus become plus, so I get rid of the sign at least. And let's see how can I manipulate the denominator. The cosec is 1 over sine of x, so this is this, times the cotangent is cosine of x divided by sine of x. So this is equal cosine of x divided by sine square of x. This is my cotangent here. So now I will study the limit when x goes to 0 plus of 1 over x divided by cosine of x divided by sine square of x, which is equal to the limit when x goes to 0 plus to 1 of x times, I will flip it, become sine square of x divided by cosine of x. So all what I have to do now is to study the limit when x goes to 0 of sine square of x divided by x cosine of x, and 0 plus here. But I know sine of 0 is 0, and if I replace x by 0, cosine of 0 is equal to 1, 0 times 1 is 0. It is indeterminate again, so I have to do L'Hopital rule again. Before I do the L'Hopital rule, let's see if I can simplify my life more. Well, you can do it here, it's the same thing, but I would like to do it in 2 steps. The first one is sine square of x divided by x time the limit when x goes to 0 plus of 1 over cosine of x. That will facilitate my life more because I know cosine of 0 is equal to 1 and 1 divided by 1 is 1. So all that would go to 1, and 1 times anything is anything because 1 is a neutral number of multiplication. So now I can concentrate here because this will become limit when x goes to 0 plus of sine square of x divided by x multiplied by 1. Multiplied by 1 does not change anything. And now sine of 0 is 0, divided by 0 is indeterminate, and I can apply L'Hopital rule again. So I know limit when x goes to 0 plus, the derivative of sine square of x is 2 sine of x multiplied by the derivative of sine, which is cosine of x, and the derivative of x is 1 divided by 1. So we don't have to account for that. I know the sine of x, this is equal to 0 and this is equal to 1. So 0 times 1 is 0, times 2 is 0. So all that is equal to 0. Perfect. Now I know that ln of y is equal to 0 because we said at the beginning ln of y is equal to this, and we developed this. We developed the right hand side of my equality. So my ln of y is equal to 0. Yeah, but ln of 1 I can write it like this. It's easier for you to understand. Log to the base of e of y is equal to 0, and then if I apply the logarithmic rule, e to the power of 0 is equal to y, and e to the power of 0, 1 is equal to y, and then I will replace y by its value that I took at the beginning of the video, which is y is equal to this. So now I have 1 over x to the power of sine x when limit when x goes to 0 is equal to 1, and that's the end of my video. I hope that you like it, and if you like my video, please subscribe to my channel. That would help me a lot, and if you put a like, I would really appreciate it. Thank you for listening.